All right, good morning, everybody. Hope you're having a great time. Hope you're having a great time at Breakpoint. It's the fourth one, I think. It's the most packed, 6,000 tickets sold. It's been a great one so far. Today, I'll introduce the topic. We're talking about SVM and EVM, and is that competitive with Solana Mainnet? First, I'll sort of introduce the topic, and then we'll get into it right after. So you've probably seen quite a few conversations on Twitter and other forums about network extensions and L2s, and whether those are parasitic or competitive with Mainnet. There are many conversations about fees and MEV and execution and DA and how these things actually affect Mainnet. Do these things actually ever roll back to Mainnet? Are you actually taking these fees away from stakers and validators and actually the important people that are sort of helping secure the network? There are quite a few different types of VMs that actually end up settling to Solana. There's the SVM, there's the EVM, there's the Move VM, and there are a few other types that end up doing bridging or sidechains or things like that. But all of it, is it competitive or is it not? We're not really sure, so that's what we're going to try to get into today. So first, we'll introduce Terry from Eclipse, and he'll give a little bit about himself and then a little bit about why he's against or thinks this is parasitic.
Yeah, hey guys. I'm not Frank from DGods. Terry from Eclipse here, head of strategy. Eclipse is building the first SVM L2 that settles to Ethereum, uses Celestia as DA. Great to meet y'all.
And then Kevin?
I'm Kevin, developer relations for Mainnet Labs, background in computer architecture and signal processing. So.
Cool. Yeah, let's get into it. First, Kevin, you're on the fore for this, right? So you think that SVM and EVM is actually competitive with Solana Mainnet. Can you explain why you think that is?
Yeah, I think fundamentally, if you're a shop owner and if someone is going to a different shop, the entry point is where you have a lot of advantages, right? You can collect fees, you can collect MEV, and so if that entry point is somewhere else that has an intermediary in between a lot of the value capture mechanisms that drive a lot of the incentives behind blockchains, then fundamentally you are somewhat competitive. Now, I think there are constructions that can mitigate that a little bit, but for the most part, and as they exist today, I think there is a pretty strong case to say that they're competitive in a multiple different ways. Even just on developer mind sharing stuff, if you have to build for multiple environments, obviously it's hard to build an Android app and an iOS app, right? Yeah. And so having to do that, obviously splits.
Yeah. Terry, why don't you think they're parasitic to Mainnet?
Yeah, so let me make a distinction here, right? Eclipse settles to Ethereum, and so when you say that it's a different shop, different entry point, it is parasitic to the fees and MEV of Solana, Eclipse is connected to Solana essentially by a third-party hyperlane bridge. Yeah. And so there are other execution environments that are also connected to Solana by the same bridge construction that are also execution environments where you can do substitute type of behaviors that might be similar things like taking out, borrowing against certain collateral. The fact that the action is similar does not make the state substitute, right? The fact that there is a wormhole bridge connecting AVAX and Solana does not make AVAX DeFi directly competitive and parasitic against the MEV and the fees of Solana Mainnet. So Eclipse, you can discuss that in the context of Ethereum. That might be a different conversation. But in the context of Solana, number one, we are not settling to Solana. We're not parasitic to the MEV and fees of Solana. But number two, state is fundamentally non-substitute in that, let me give you a kind of concrete example here. Say the emergent behavior on Solana DeFi is that I deposit Solana or Jito Solana, and against that I borrow PayPal USD to buy WIF on Jupiter. None of those assets, first of all, exist on Eclipse. So fundamentally, because the state is non-fungible and non-substitute, you cannot even do the action that would generate MEV and fees on Solana Mainnet on Eclipse Mainnet. So on Eclipse, what you might instead expect is I would deposit Ethereum, and then I would borrow Solana. And thereby, I would gain exposure to the Solana asset instead of, say, doing something that can be directly correlated, directly doable, and substitute on Solana Mainnet.
I mean, I guess I could just say that's the same argument from the Solana side. It's I could do Solana-denominated Ethereum DeFi, right, with the same trust assumptions as a bridge over using Wormhole with Ethereum assets on Solana. And so in that sense, if you own the door to the store and customers are coming into your store and your store takes fees on the activity that the customer is doing, like I still think that's competitive.
But yeah, fundamentally there is no, like there isn't a trustless bridge to Solana from Ethereum. And so therefore, kind of the state that exists on Solana, that is Ethereum DeFi adjacent, is significantly less than what is going to be there on Eclipse. And by that argument, you could also say, yeah, there's not going to be a lot of trustless Solana deposits on Eclipse because of that argument. And that's fair, because I think that even puts us further away from the parasitic and fees argument, because if we have full assets in state that is much more Ethereum DeFi adjacent, taking advantage of the SVM execution, that gives us a completely different use case compared to what is possible in Solana mainnet.
Okay, so he just said state there, right? So Solana was originally built and envisioned to replace NASDAQ, to replace traditional finance, and a lot of what Tolly says is a large integrated state machine where anybody around the world can access that state, right? Historically, you'd think that L2s actually fragment state, right? That state is actually partitioned amongst multiple L2s, and I'm not really sure if that actually changes it if you actually sort of settle back to mainnet. So can you talk more about this sort of like integrated versus modular approach and actually how does state fragmentation actually affect the SVM and EVM?
Yeah, I mean, like, I think fundamentally, like, you are fragmenting state, and like the value prop of Solana is to unify state, and like that is competitive, right? It's a competitive vision of what one layer is used for versus another layer, right? And so, yeah, I mean, like maybe there is different state over there, but I mean, I think the point of Solana is to eat the world state, right? And so if we can get that state representation on Solana, I think that is the goal, right? And if you're not doing it, it is competitive.
Yeah, so my response to that would be, that puts any execution environment fundamentally competitive with any other execution environment. It makes Monad competitive with Ethereum. It makes Monad competitive with Solana. It makes any ETH L2 competitive with Solana. Because we are fundamentally, and I kind of repeat this a lot, is that we are SVM rollup settling to Ethereum. And in fact, the way I like to think about it more is that we're kind of like a beachhead that it's like a Solana infiltration into the Ethereum ecosystem, right? And kind of what we've experienced firsthand is there are quite a lot of EVM dApps that come to us as the first entry point into coming into the Solana ecosystem. They're like, hey, Eclipse, you guys are an EVM or you guys are ETH L2. Can you please help us port our contracts over into Rust? And once we do that, that is kind of the upfront work that it takes for them to also deploy on Solana mainnet as well.
I actually wouldn't really disagree with that in some sense, because like as Monad, we see this a lot, right? A lot of the entry point into the EVM is coming over to Monad. But there is an element of if you want to be the world's global synchronized state machine, right? I do think all L1s and L2s have an element of competitiveness, or like, why would we be here, right? Like, I think we're all kind of in this world of trying to be the best, like otherwise we wouldn't be building the technologies that we're building. And while some of these things are symbiotic in ways, in expanding to like different audiences, like I said before, like it does split developer activity and time in some ways. Like fundamentally, I think if you're an app and your expansion plan is just to go to another chain because you didn't find product market fit on the original chain, like I don't know how that's supposed to solve the problem, right? And so like a lot of these apps who like want to come over to Monad, like it's great, but like we would like to see them innovate on what's possible on Monad, right, within the EVM sphere, and like really push boundaries of like actual product market fit and new use cases.
Yeah.
Right?
All right, so let's move on to fees and MEV, right? So why, if an L2 has some other execution environment, non-consensus, but still sort of doing like top-of-block ordering or sort of building some block and sort of posting that state back to mainnet, like why when you're taking MEV as a sequencer, or why are you taking sort of fees away from the L1? Why is that not parasitic?
Yeah. So in the context of the debate, we're discussing whether SVMs on Ethereum are parasitic to Solana. But the question you posed was, if I'm taking fees and MEV away from the L1 that I settle to, why is that not parasitic to the L1? And fundamentally, here the L1 in question for us is Ethereum, right? And the argument against that I have is that Eclipse, by that network, is a network extension on top of Ethereum, in that what you can do on Eclipse is fundamentally something that you cannot do on mainnet. And this is by definition because we are an SVM, and Ethereum mainnet is an EVM. So all the applications that exist and all the kind of activities that are fundamentally doable that are only doable on an SVM that will deploy to Eclipse are, again, not possible on what the L1 is.
Yeah. Thoughts?
I don't have a disagreement with that, honestly. Like, if you're building an SVM on an EVM, obviously you can do like different things on it, right? But I do think like as layer 2, you are being like this middleman between MEV, right?
Yeah.
That you're capturing that's not going to the L1. Now, I do think there's a world in which you can build smart contracts that capture MEV for applications, right? But the L1 still determines like congestion fees, especially if your blocks are full.
Okay.
And I do think that's like fundamental to actually incentivizing the validator set to find value in running the chain. And if the L2 is capturing that, right, it's like actually diminishing like the value prop of being a validator on the L1.
Yeah, understandable. All right, so next let's move on to mindshare, right? So if you're building an SVM, maybe using the SVM API, right, and settling to Ethereum, right, you're actually not using the same clients that the traditional L1 is using with Agave. You're probably using a fork. You don't have a consensus involved. You probably have like direct mapping, these feature gates that aren't even activated yet, these new curves. How do you sort of think about that separation between the SVM that's forked and used by the L2 and then the L1 that might not actually upstream any of those changes?
I mean, historically, we haven't seen a lot of upstreaming of changes, right? The way that it's worked so far is like the mainnet client is then forked and pared down for the other use case. I haven't seen a lot of contributing back to like the actual core client, and so I mean, I'm more of looking at like what has existed till today and just saying like I haven't seen evidence of that.
Yeah, I think that's it's a long cycle, right? And I think the ETH land has a bit more examples here, where especially a lot of the zk-L2s, they pioneered and even invented all these new proof systems as well as optimizations to existing proof systems that are now being used to extend in coprocessors Ethereum compute and or even in the future ZK prove layer 1 blocks. And if we get to the point where Ethereum itself is ZK proving layer 1 blocks using some of the proof technology invented by the layer 2 teams, namely ZK Sync, Starkware, and Polygon, that is a significant contribution of these roll-up teams back to the future roadmap and the capacities of the L1. And with SVMs, like frankly, we've been live for, I don't know, like 2 weeks, 3 weeks at this point. So like it is a little premature for us to discuss like, what are the core contributions we're making back to the Solana ecosystem, to the Solana client, to the Agave client. But it is definitely something that we're very mindful of and something that we want to achieve in the future.
Yeah, makes a lot of sense. All right, so can you switch? Right, so
yeah.
when is it not parasitic, right? Like when do you think SVM on EVM that sort of settles to Ethereum is not parasitic or it's not competitive to Solana Mainnet?
Yeah, I mean, I think like as far as developer tooling, like that's something we've even seen on the EVM, like the proliferation of the same execution environment, it motivates people to build auxiliary tooling for these ecosystems that ends up being very helpful for app migration and adoption and stuff like that. I also think that a construction with a based rollup actually does make a lot of sense, and I think this is what network extensions on Solana are. They're just fundamentally like based rollups, right? So their fees go back to the sequencer sent. So I do think there's constructions where it is like actually symbiotic, and I do think there is some developer mindshare things, especially honestly, like the vendor lock-in stuff. Like it's good for a developer to feel like they can go somewhere and not be completely tied to a single ecosystem. But again, like if you're not finding product market fit in your app and you're just like hopping from chain to chain to try to expand your user base, like I don't know that that's going to fix your problem. I think like you actually have to expand with product market fit and stuff like that.
Yeah. All right. So when is it parasitic and competitive to mainnet?
Yeah, I think there is a case to be made, say, when we have exhausted the kind of expansion of growth in crypto such that it is really a PvP ecosystem and a closed loop system, right? Like the number of developers that we're going to convert into crypto and build in crypto is absolutely finite. And in that case, if you're competing with a product that is purely based on SVM execution, it has nothing to do with non-substitute state, then yeah, it is competitive there. But I think we're kind of far away from that world.
Yeah, fair point. All right, we have 5 minutes. Maybe let's get into technicals. But first, I want to actually get to one thing. So why, or like what types of developers want to build on SVMs that settle to Ethereum? Like what do you actually gain by doing that or like building on Eclipse?
Yeah, so one interesting cohort that we've seen is Ethereum developers that are Solana curious. And I think there are quite a lot. And they see us as kind of an easy entry point, right? It's not, say, oh, we're leaving Ethereum for Solana, but it's we're deploying to an SVM L2 that is also an Ethereum L2. and therefore, we are already on XYZ Ethereum L2. It is just a cross deployment. But by doing that work, obviously, they're also going to go to Solana Mainnet. So we've actually seen quite a lot of inflow of developers like that who have said, hey, Eclipse, can you help us like port our contracts into Rust? And then, of course, I do expect them to see them on Solana in sometime in the future. That's number one. Another use case that I personally am excited about is Solana ETH DeFi. So we have a trustless bridge from Ethereum, so we expect a lot of Ethereum assets. I think just because of our VM association, we will see Solana assets that cross over from some path or another onto Eclipse. And I'm personally excited about things like using ETH collateral to borrow Solana, using ETH collateral to lever long Solana perps, just by like the type of exposure in terms of assets that I've wanted. So that's something I'm pretty excited about.
Yeah. Why do you think people should just build on an integrated chain, like on a Monad or on a Solana? Like, why should you pick that over an L2?
I mean, I think like composability is like a fundamental property of blockchains. I also think that when you start looking at external DA, like you can't get around the fact that you're adding a network hop, so there's like latency games that start happening. And like you compound this with execution layers that are like going at speeds where the stuff starts to matter, like the latency to the DA like starts to matter when you have a lot of like value in flight, right? And then you have to like, for a user, you have to reason about all these trust assumptions. As an app developer, you now have to pick different stacks, right? I think a lot of apps would rather just have like an integrated stack and be like, this is my full stack solution. Things just kind of work here. And I think we've seen that in a lot of different integrated environments.
Yeah. This kind of sounds like an integrated versus modular debate. And here's where I want to point out that Celestia is going to get to 1 gigabyte blocks on mainnet significantly faster than Monad can get to the same DA throughput, simply because they don't have to focus on things like execution, and they don't have to focus on all the other innovations that Monad is driving in the ecosystem, which are beneficial to their stack and execution of EVM and faster execution there. But fundamentally, just by focusing on one thing, they're able to come up with all these new innovations that increase DA throughput, that increase verifiability while increasing DA throughput, which is also very important. And that's kind of the whole idea of modularity, right? By specializing, you have people who are just working and focusing on one thing, and that improves at an exponential pace faster than people focusing on the whole integrated environment.
But I would actually argue you're actually like introducing latency to verifiability, which the property of a blockchain that you want to have fast is the verifiability of the data.
Not verifiability of the DA layer, because that's just a DAS-like client on Celestia, but verifiability of the L2 blockchain that writes their DA to Celestia, because you have that, again, you said the latency ping of reading from a separate DA layer.
Right, whereas in an integrated chain, you're just reading the hard drive.
But today, Celestia is infinity times more DA throughput than Monad, because Monad is not live, but once it is live, right, I'm not quite sure what gigabyte blocks or how much gas per block you are going to have, or DA capacity that you are going to have. Celestia is just going to be like 100 times more.
We'll see.
We'll see.
So we have 2 minutes left. Maybe let's try to get into the technicals. Like, what do you disagree, or what do you have hot takes against sort of SVM on EVM that settles to Ethereum, right? Like, what are things that you don't think work, like censorship resistance or sort of like state STF proving?
I think for me it's more of just like the L2 trade-offs, is like you're losing real-time censorship resistance. And they talk a lot about like, oh, well you can exit, but like there's actually delay to that exit, and for financial markets, that can be like very, very impactful, right? And so like if you have to get in line, like markets are moving in real time, like you want to get your orders off the book, you want to like place bids and cancels, and if there is a situation where real-time censorship resistance matters, like for global finance, that's like actually incredibly important, and the risk that market makers have to take on things like order books that we're hoping that these new scalable, environments enable, like the risk for the market makers on that order book could go up exponentially.
Yeah, totally agreed. So real-time censorship resistance problems in an L2 exist because you have one centralized sequencer, and the kind of question that people pose is, okay, if that one centralized sequencer, which is run by the sequencer operating company, starts to censor your transactions, what happens to my, say, collateral that I'm borrowing against that can then be liquidated and or censored, whatever, right? So I think the core question I have to pose in the last 30 seconds here is, what happens if you just simply increase the number of sequencers? What is the minimal viable set such that you do get real-time censorship resistant guarantees while not incurring the overhead of massive consensus set over a permissionless validator set?
I would like to know that as well, because if we have multiple, like honestly, at a point where you're having like multiple sequencers, like you kind of have to have, I guess in a rotating sequencer you don't have to have that, but like I don't understand why you would just not use the base rollup where your sequencer set is the L1 itself, right?
Right, because that's kind of two ends of the spectrum, right? You have one sequencer and then you have the full entirety and censorship resistant guarantees of the L1 proposer set. But my position is that with PBS, we have already seen builder centralization to the fact that where the vast majority of blocks are actually built by a few entities. And I think most blockchains, the financial incentive is there to go to that direction, in which case is there a number that we can choose in the middle of the spectrum where you get that censorship resistant guarantees in real time such that it is sufficient for DeFi to flourish while not having to incur the overhead of going all the way here.
All right, we're at time. I hope that was interesting for you. All three of us will be around at breakpoint. Hope you have a great last day and have a great rest of your day.